Thank you, John. Good morning, everybody. Yes, I'm David Cotton from Satellite Oceanographic Consultants, or SATOC, and I'm going to take you from the cities to the coast. Sea Level Space Watch is a joint project between SATOC and the National Oceanography Centre. It's looking at providing UK government agencies with information on trends in regional sea level, which is important to provide improved assessments on vulnerability to sea level change and to help identify priorities in flood defence for the future. To look at future flood probabilities, coastline positions, and also help provide better information on the impact of coastal squeeze on coastal marine habitats. And our solution is operational web-based sea level monitoring service which brings satellite altimetry data and tide gauge data together. We've generated a time series of altimeter sea level data, currently 14 years, and used that together with the tide gauge data to provide trends in sea level interannual variability, and then allowing us to produce analyses on regional variability and so on. So first of all, I just want to look at the problem and the user requirements of sea level data. So we've been working closely with the Environment Agency, Owen Tarrant, with Natural Resources Wales, Rick Park, and the Committee on Climate Change, Catherine Humphreys. So I want to say thank you to them from the beginning. They provided a lot of valuable input as to their requirements. And so the basis is that mean sea level change strongly governs future flood probabilities, and improved information on sea level trends will support decisions on the timing of investment decisions, which are expensive, and we need to take action in time to avoid unacceptable risks. We need to know when to make the decisions to improve coastal defences in certain areas. And as I say, the costs are really quite high. So from the EA perspective, there's £2.3 billion planned spend in England over the next 6 years on flood and coastal risk management. And that's expected to increase because we know that the probability of floods is going to increase. We also want to know how sea level rise will impact on shoreline management plans and coastal habitat. There are many hundreds of hectares of coastal habitat potentially at risk, and the cost of providing compensatory habitat to replace that is expensive. So underlying all of that really is we have these predicted trajectories of sea level change, and we want to be able to relate those to observe sea level trends and be able to understand what's happening better. And to understand if those effects are broadly consistent across the UK, or are there regional trends, regional variability around that. So a bit of background. What we know about UK sea level variability currently is based on information from the UK tide gauge network. So there are 40 kind of top quality tide gauges around the UK, which have been going for some of them for over 100 years. And analyses of those data have confirmed that over the past 100 years, we've been seeing an average increase in mean sea level of 1.4 millimetres per year. And looking at regional change around that, the main cause of regional change is post-glacial rebound. So we know that the north of Scotland is lifting up, and the south of the UK is going down. So in fact, sea level rise respected to the land is greater in the south than it is in the north. So that's the main kind of cause of regional variability. There are other sources to do with atmospheric variability and oceanographic changes in currents. And there are also impact on extreme. We know that there are increases in extreme levels related to this increase in mean sea level. And analyses have now also shown us that the mean tidal range is increasing. There's more water in the oceans. That affects actually the tidal range as well. So what you see on this figure on the right is a land movement map. So the orange is showing where the land movement is rising, and the blue is when the land's decreasing. And in the centre, there's tide gauge, mean sea level, year on year, respect to Newlyn. Newlyn is down on the southwest coast in Cornwall. So you can see that in the north in Aberdeen, the sea level is going down with respect to Newlyn. So this is all from what we know from tide gauges. In terms of, and that's what's happened in the past, but in terms of what's happening in the future, we're relying on these climate projections. On the global scale, there's the IPCC projections, and globally, mean sea level is projected to rise by over 50 centimetres over the next century. But there's a lot of uncertainty in that estimate. So you can see measurements on the right-hand graphic. You see where the measurements are and then where the projections go from year 2000 onwards. The red line is a high emission scenario, and the uncertainties on that are the kind of shaded area. The blue line is if we have a really aggressive reduction in emissions, and the uncertainties on that are in blue shaded area. But even with a really aggressive concerted effort on reducing emissions, we know that sea level is going to continue rising over the next century. But it's not uniform over the globe. We know there's variabilities, and some places it's going to increase more than others. And it's not a uniform in time either. So there are kind of decadal variations. So you can kind of see these ups and downs on the overall trend. And there's also an annual cycle related to that. So if we're going to try and compare what we're seeing on the ground to what's being predicted, we need to understand all of these patterns that are going on. And around the UK, so UK CP is based on an ensemble of models looking at different climate scenarios, includes those various contributions that are shown. And so what was in UK CP09, this is the kind of projected rise, and you can see that the modelling is really quite coarse. It's got a kind of general overlay of this post-glacial rebound on top of a larger scale picture. And those are the figures in UK CP09 for the expected sea level rise with respect to 1990 for London, Cardiff, Edinburgh and Belfast. So by 2050, the middle of that range, we expect sea level to have risen by 20 centimetres in London and Cardiff, by 14 centimetres in Edinburgh and 15 centimetres in Belfast. But again, you can see there's quite a range over the different scenarios. So what we want to be able to do is better pin down what these projections are saying and relate them to what we're measuring on the ground to be able to give people a better basis for planning. So that's where our satellites come in. A quick tutorial on satellite altimeters. So it's a nadir pointing radar looking directly down from the satellite, radar wavelength of around 1 centimetres. These things are orbiting between 800 and 1,300 kilometres. And, fairly easy calculation. Time for the echo to go down to the reflecting surface and back up again gives you the range. If you know where the satellite is precisely, then you can get the height of the reflecting surface with respect to a reference surface. This is well-known technology. It's been going on since the 1990s. And now, with current processing, you can get absolute accuracy of one measurement down to 3 centimetres, but a precision, if you do your averaging, to millimetres, order of millimetres, which is why we can say from space now we can measure trends of global sea level in millimetres per year. It also measures waves and winds, and currently we have missions on different orbits. So that's important because you can see that the sampling that you get there from a 10-day orbit. So each of those tracks is repeated every 10 days with that kind of separation in space. If you change for a longer repeat orbit, so each of those tracks is only repeated every 35 days, then you get a much higher spatial sampling. At the moment, we have satellites in both of those orbits, and we expect to continue that now with the JASON series and Sentinel-3 series in the Copernicus program. We know that they're going to continue that kind of monitoring pattern for the next 15 years at least and beyond. So what we've done in Sea Level Space Watch is we're bringing together tide gauges and satellite altimeters. From the tide gauges, we get continuous monitoring at a specific number of sites, and that's the tide gauge network I showed you before. From satellites, we get this spatial picture. So we want to bring together the best features of both, if you like. We can get good temporal sampling from the tide gauges, and we can get good spatial sampling from the satellites. Provides us with a bit of a problem trying to analyse the satellite data because we're just picking out points of the tidal cycle. So you have to understand that. You have to be able to correct for that. Now, satellite altimetry has been accepted as for open oceanography as providing climate quality sea level data, but the challenge has been providing data up to the coast, which is where this project comes in. At NOC, National Oceanography Centre, they're leading the international community in being able to reprocess the altimeter data to give you good measurements right up to the coastline. It's a whole load of development, technology and understanding in there, but this is the basis of this project and where NOC's expertise have come in. What happens is as soon as the altimeter sees the coastline in its footprint, you get kind of strange echoes, and you need to be able to process the data to take those out. So, NOC has reprocessed 14 years of historical data from the JSON and MVSAT series of satellite data. They produced this coastal sea level time series. We've put that together with the tide gauge data, and we generated long-term trends and analyses of the annual variability on that, which has allowed us to put together a zoomable web interface, which shows the satellite data together with the tide gauge data, and you can go in and you can pick out the underlying data with that if you want. And we've also put on there, on the right-hand side, we've put on the projections from UK CP09, so you can compare what we're seeing with the satellites and tide gauges with what's being predicted from the climate projections. And on top of that, we're providing analyses at key locations where there's sufficient data to do kind of detailed studies. But this is a kind of mock-up of that, one of those examples for Holyhead, where we've got a number of tracks coming in. So we're putting together the altimeter and tide gauge data. We're including what we know about land movement and putting in there the model sea level changes. But it's important to give some guidance about how to interpret those data, because you're kind of seeing different things from different data sets, and it can be easy to jump to the wrong conclusions. One of the problems is that the modelling, the climate scenarios, are actually modelled for open ocean. You saw earlier on how it's really quite broad brush. It doesn't go into detail of what happens in the estuaries, and that's where you've got the long time series. And again, that's where the satellite data comes in. It allows you to make the connection between the offshore modelled changes and what's happening at the coast. So with this guidance, we can provide some assessment of regional patterns of variability, some analysis of errors, and some advice on how to correctly use and interpret the information. I'm not quite sure quite how well this shows up, but these are some kind of new scientific findings from this study. So on the left-hand side, the sea level trends from 14 years of data, and that's showing us that we are seeing an increasing trend around the UK coast, but it varies. So the highest trend is at the south, the lowest trend is at the north. And if you're looking at this annual pattern that you want to understand, the annual cycle's highest in October in the southeast, but this peak occurs later in the northwest in November. And just getting signed, so I better get a move on. We had a workshop end of March with our users, with some sea level experts, to look at these data and to work out a way forward. We identified the benefits of the service are that will provide greater confidence in planning investment on coastal defences and coastal habitat management. As I said earlier, the cost of coastal management is immense. 30 billion assets in England are £30 billion, and we know the cost of replacing coastal habitat is hundreds of Ks, order of 100 Ks per hectare. So if we can provide an improvement in efficiency of just 0.01% in managing efficiency in managing our planning, then the costs will be recouped. We're only really talking about tens of thousands of pounds a year to run our operational service. So where we're at in terms of implementation, we're having ongoing discussions with the end users. So this is with NRW, with the EEA, with SEPA, Scottish Environment Protection Agency also, looking at potential consortium funding model and hoping to have a operational implementation in autumn this year. There is a a lot of scope for international implementation, working with partners across the North Sea and also in vulnerable areas, vulnerable low-lying areas, particularly in the Indian Ocean, where the infrastructure is not so great. Just one quick slide on generic lessons. So, kind of obvious things, I think, but it's worth saying. Early engagement of users is critical to understand what they need to guide our development and focus efforts in the right places. We need flexibility on both sides so that they kind of understand the data better, we understand their needs better. We need further data to improve our estimates on long-term trends. If you're trying to estimate trends from a short section of data, there are errors in that. You can bring them down by bringing in more data. And we talked about also ways to improve the refinement, the presentation of the data, maybe to look at providing regional information rather than locational information. I want to thank the SSGP. They provided us with connections to user agencies, but also the kind of financial input was essential to bring people together and to get this demonstrator going. So I think this is pretty much the final slide. In conclusion, Sea Level Space Watch is confirmed to be of considerable interest and potential value to government user agencies listed there. We need to refine the service a little bit, but this is really a few tweaks and should allow us to get operational implementation up in the autumn, and a scope, as I say, for extending the service overseas. Read out a few user comments. Sea Level Space Watch's programmes work to improve and summarise satellite data on sea level rise around the UK will be an extremely useful contribution to our work. In particular, regional average data on observed sea level trends to date is a key gap in our current suite of indicators. It's essential we have quality data and information on trends in regional sea level trend. Spatial resolution of the data derived from Altimetry provides valuable insight into regional sea level variations. I won't go through the whole lot. Thanks again to our partners from NRW, from the EAA, from Committee on Climate Change and NOC. Ready to receive any questions?
There's one at the back, John, thank you.
Hi there. Crispin Hammond, EA. Just wondering what restrictions there would be in estuarine environments. So, from the point of view of the shape, size, and location of estuaries, in terms of being able to get viable measurements.
What restrictions there be on the? Sorry.
So, the shape and size of an estuary. Would that what's the kind of minimum size of estuary that you'd be able to get measurements? And are there kind of shape criterion as well?
So the short answer is it is if you have a complex coastline, it gets more complicated trying to retrieve a signal. But with the new processing and actually with there's a new type of instrument, a satellite altimeter on board the satellites now, which do mean you can get measurements right up to the coastline now, resolution about 300 metres along track. The real difficulty is actually in the tidal corrections in those estuaries, because that's a critical problem at the moment, and that allows you to relate the satellite data to the tide gauge data.
Okay, thanks.
Any further questions for David? Well, thank you very much. As I said earlier, David and other speakers will be around at lunchtime if you want to find out more about that project or any others.